This is Scott Howard with Buyers Security. In this video, I'd like to discuss some recommended best practices for deploying the Tofino industrial security solution in your plant network. First of all, some general guidelines. What we're trying to do, as much as possible, is just create firewall rules and other security configuration in the Tofino system to permit only the bare minimum set of network traffic that is required for your plant to operate correctly. And anything outside of that minimum set of traffic, we want to block and generate alarms. This will give us the best overall security. So this means that, first of all, we want to be able to specify our firewall rules as tightly as possible. So wherever we can, ideally, we would like to use talker rules rather than global rules. Global rules provide the opportunity for devices other than the intended ones that we planned for to pass traffic through the firewall. When we create talker rules, then only the devices whose IP addresses we've identified in those talker rules are going to be able to pass traffic through the firewall. Now there's kind of a middle ground here as well, where we can use a network icon as a talker in the Tofino firewall rules, and I'll show you exactly what that means. Now most times when we create a talker rule, it's a one-to-one relationship between a protected device, in this case the PLC, and a talker device, which is in this case the HMI. If we look at the settings for the HMI device, we can see that it has one specific IP address assigned to it. However, it's also possible to use a network icon as a talker. That is a special icon that's here in the nodes view, and in fact every Tofino deployment with CMP includes at least one network icon, because the plant network, this item at the very top of your network diagram, is also a network icon. If we look at a network icon, you can see that it actually does not have just one IP address assigned to it. It's got an IP address range or subnet. And the range is formed by the combination of the base network address and the network mask. So in fact, this plant network has, in this case, 256 possible IP addresses assigned to it. And when we use plant network or other network icons in firewall rules, then that rule applies to all addresses that make up a part of that address subnet. Let's do an example of this. Again, let's say we want to allow any device in our plant network to send a ping command to this PLC. Let's go ahead and do that. We could do it with a global rule, and in this case we would just add ICMP ping to the global rules on this PLC. That means any device can ping this PLC. That may include devices that we didn't intend to allow this to happen. Let's not do that. Instead, let's create a talker rule with the plant network. So we'll drag the plant network icon to the talker rules list, and now we'll add ICMP ping to that icon. Now we're allowing any device with an IP address in the range covered by this plant network to ping the PLC. So that's a way we can tighten up the definition of that ping rule, so that the devices we care about are able to ping that PLC. Other devices that we didn't intend to allow to do that will not be allowed to send ping to this controller. So there's a simple example of how we can use a talker rule to get the specific security that we need without making it too broad. Always a good idea and always recommended to test your configuration using the test mode of the Tofino. Do all of your testing in test mode until you've got all of your rules checked and working the way you want, and then switch the device to operational mode. I'm guilty of breaking this rule in these demo videos because I was rushing to show how to create certain types of firewall rules or other configurations, and I was ignoring some traffic that was not being handled by my firewall rules. And that's always a temptation in a real system deployment. It's really, really important to do all of your testing up front before you actually make the device operational. And that leads us to a discussion of the 3 golden rules of Tofino deployments. Rule number 1, no heartbeats. Rule number 2, no heartbeats. And finally, rule number 3, no heartbeats. I can't overstate this. You really want to make sure you have rules that handle all of the normal network traffic in an appropriate manner, such that you only receive a heartbeat when something abnormal happens in your plant network. Okay, these heartbeat messages, they're alarms. They're telling you something is wrong. If you have not completely and correctly configured your Tofino so that no alarms are generated for normal plant operation, then you run the risk of filling up your alarm logs with false alarms. And if that happens, then if something bad really does occur, it's going to be almost impossible to find, depending on how many false alarms are being generated. So let's do this the right way now. How exactly do we go about configuring the Tofino so that normal network traffic is not generating any alarms at all? And so it really boils down to finishing the job in test mode. Go through every single alarm message that shows up while you're testing. Continue editing and testing your firewall rules and cycling your plant through any particular operating modes that it may be capable of, and make sure you get through all of that without any alarm messages. Once you're at that point, then you can be relatively confident that you're not going to be filling up your log messages with false alarms. Let's do that now on our sample system. I've let it run for a while. You can see that there's quite a few alarms that have been generated since I first set up my my simple set of firewall rules. Let's go through them and see what we're running into. First of all, well, let's go back to the beginning. We have traffic here. It's UDP port number 6061 coming from an unknown device at IP address 1.7. What do we want to do with this traffic? Well, the first rule of putting a device like a firewall in a control network is do no harm. We want to investigate every one of these alarm messages, try and understand what device is generating the traffic, what the traffic is, and what's the appropriate way to handle it. And if our guiding philosophy is do no harm, then that would mean if we don't know for sure that it's safe to block the traffic, we should let it through. Now I dug into this this traffic a little bit. I discovered that this is coming from an IP phone that's on the same network as my PLC. And reading through the documentation on the phone, I realized that this is a protocol related to music on hold for the IP phone. Now, I'm pretty sure that my sample chemical blending plant is not going to malfunction if I block this traffic. It certainly does not need to get through my Tofino security appliance to the PLC. So for this traffic, I'm going to go ahead and block it. I'm so sure that I don't need this traffic getting through the Tofino that I'm going to block it in a rather crude manner. I'm going to go to the global firewall, the global rule list on my Tofino's firewall tab, and I'm going to set a rule here. Before I do that, first of all, I have to create a protocol definition for this protocol. I'm going a little fast here. Let me back up and show you what I'm doing. So I'm going to start by creating a protocol definition to match this traffic that I'm seeing. Let's go back and look at it. So it's UDP port 6061. Let's create a protocol that matches that. So I right-click in the protocol view, I click Create. I have a choice here of what type of protocol I want to create. I'm going to create a protocol for TCP or UDP protocol. So I select that option, hit Next. I'm going to give it a name. I'm going to just call it UDP 6061. The port number is 6061, and it's UDP. Once I make those selections, I can hit the Finish button in this wizard, and now the new protocol is created. If we look in the protocol list, you can see that that protocol now exists in my list. Let's make a rule to block this traffic. I'm going to create a global rule on the Tofino Firewall tab. And this is a bit of a crude and blunt instrument, but in a case where I'm very sure that I don't want any traffic of this nature to get through, it's very effective. So on the Tofino Firewall tab, this is where I can create global rules that apply to any device that's upstream of the Tofino and any device that's downstream. So I don't care where this traffic is coming from. I don't care where it's going to. I'm going to block it, and I'm going to block it by changing the permission on this rule to deny no log. That means don't let the traffic through, and don't generate an alarm message. So deny means block it. No log means no alarm message. So there we go. I've made that selection. That rule is now being downloaded to the Tofino. What else are we seeing here? Here's some traffic coming from some device on address 1.5. I looked into this. This is a router on our test network, and the protocol is universal plug and play. This is one of those nuisance protocols which is frequently generated by consumer electronic products like printers and routers, and Windows PCs also very often generate this protocol. This is not a protocol that we need on our control network. So once again, I believe I'm very safe in blocking this universal plug and play from reaching my Modbus controller. Let's do the same thing for this protocol that we did for this mystery UDP 6061 protocol. So I'm going to add a rule on the Tofino's Firewall tab, set the permission to deny no log. With that new rule in place, we should never again see any universal plug and play traffic coming from this router. Let's take a look at some other traffic that we're seeing on this network. That's going to take care of a lot of it. Alright, here's another one. This traffic is with UDP port 137, 138, and 139. This is a special category of traffic coming from Windows PCs, and it's called NetBIOS. We're going to deal with NetBIOS in a couple minutes here. Okay, so there's a fast introduction to the recommended procedure for making sure that we have a rule to handle every single type of traffic that shows up on our network. Now, in fact, in most networks, there's going to be more than one Tofino. Of course, in these videos, we're using a very simple example network, only one Tofino, one talker, one protected device. That's not realistic. Most plants have 6 to 20 or more Tofinos. So, very important when you're configuring and testing multiple Tofinos in a plant network, leave them all in test mode until all your Tofinos are configured and they're all allowing traffic through with no alarm messages. We always want to make sure that all the Tofinos are in test mode so that they're not potentially impacting the traffic that is being seen by the rest of the Tofinos or the Tofinos that we're still working on. So they all stay in test mode until they're all configured and tested and running correctly, and then we change them all to operational mode at the same time. Alright, let's talk about NetBIOS. So NetBIOS is a protocol that we're almost always going to see in the network when we have Windows PCs. And almost every plant these days will have Windows PCs in the control network to manage and monitor the various PLCs and RTUs. NetBIOS is a protocol that Windows uses to locate other Windows PCs and to implement several higher level services such as file sharing. Now, there's a choice here that we need to make about whether or not we let this traffic through. Most controller devices, most non-Windows devices, do not need NetBIOS traffic in order to do their job. You will sometimes run into cases, however, when you have Windows PCs on both sides of a Tofino appliance, and it's very likely in that case you will have to allow NetBIOS through that particular Tofino device. This is very common, for example, when you're using Tofino to protect networks of OPC clients and servers. It is quite possible for OPC clients to connect to their servers using only the IP address of the OPC server, but it's much more common to see OPC clients configured to connect to the server by way of the OPC's server's computer name. And in order to resolve the computer name down to an IP address, you must have access to these NetBIOS, to these Windows naming services that run on top of NetBIOS. So we're faced in that case with a situation where we must allow NetBIOS through any Tofinos that are isolating OPC clients and servers. Okay, so how do we do that? It's complicated. We need to allow, first of all, broadcast traffic to come through the Tofino for these protocols from the client and server PCs that need to find each other. And then we also need to allow Unicast traffic to come between through the Tofino between client and server PCs. There's a more detailed discussion of this topic in the video that deals with the OPC Enforcer module. So I would recommend that we defer this discussion to looking at that video. If you're running OPC, you probably need to deal with this, so that's why we have covered this topic in the OPC video. If you're just using Tofino to isolate controllers from Windows PCs, then you can probably use the global rule with the deny no log permission, just like I did in these examples here, to block that NetBIOS traffic from reaching those controllers. That's generally safe to do in a case like this where we have Windows PCs only on one side of the Tofino and the only type of device on the other side is an industrial controller. One other issue we run into quite often is the topic of non-IP traffic. Now, most industrial protocols are based on IP. They use the IP addresses that are assigned to devices, and they typically will communicate on a protocol that's based either on TCP or UDP. However, there's a number of protocols that do not use IP or Internet Protocol at all. So if you are using, for example, Cisco switches or routers in your plant, you're probably going to see some of these non-IP protocols, such as Spanning Tree Protocol, Cisco Discovery Protocol, or Loopback Protocol. If you use Windows 7 or Windows Server 2008 PCs anywhere in your plant, you're going to probably see IP version 6. And then there's many other protocols that might show up depending on the equipment that's in your plant network. So how do we deal with these protocols? First of all, there's one particular non-IP protocol that we handle specially in the Tofino. It's called ARP, Address Resolution Protocol. This is the protocol that devices use to resolve an IP address down to an Ethernet MAC address. That traffic will pass through the Tofino by default without you adding any particular firewall rules to your configuration of your Tofino. Now there is certain cases where it's useful to limit the rate at which ARP is allowed to pass through the device, and we have a set of special rules that can be used to do that. Most non-IP protocols have an Ethernet type number that is greater than or equal to the value of 1500. For those protocols, they can be edited directly, and rules can be created directly for those protocols using the normal mechanism that we've already played with. I'll give you an example. One non-IP protocol we see very often, especially when there are Windows 7 computers in the network, is IP version 6. So we have a definition for IP version 6 in the protocol list of CMP. Let's take a look at that definition. You'll see that its Ethernet protocol number, or Ethernet type number, is this hex value 86DD. If we have IP version 6 in our network, and let's say we do, and we want to let it through the Tofino, that's very simple. We can use this protocol like any other TCP or UDP protocol. We can create rules for it, and we can allow that traffic through or block it as desired. No problem. There is a certain category of non-IP traffic which behaves a little differently. It has an Ethernet type number that is less than 1500. Some protocols that you will see in a plant network will fall into this category. For example, spanning tree, Cisco Discovery Protocol. These protocols cannot be used in rules in the same manner that we've done up until now. To handle these types of protocols, we use another category of rule in Tofino CMP. It's called special rules. Let's go back to CMP here. You'll notice that overlapped with the list of protocols in the bottom right corner of the software, we have another view called special rules. These rules do a variety of special filtering, for example, rate limiting, and also management of certain specialized protocols. Let's take a look here, and sure enough, we have a couple of special rules here for spanning tree protocol. The trick here is identifying when you see non-IP traffic in your network. You need to figure out what is it, which special rule should I use. Now the best approach for these types of network protocol, call your local Tofino technical support specialist. He has some tools that will simplify the task of identifying that traffic and helping you to figure out which special rule is appropriate. It's almost always spanning tree. That's very common. The next most common would be the Cisco Discovery protocols. Sometimes we run into cases where it's neither of those two and you need help to figure out how to handle that traffic. Call your local Tofino technical specialist and he can help you sort that out. Just a couple other housekeeping points. Very important that you keep a backup of your CMP database, preferably during configuration and always at the end of configuration. Now all of the configuration settings, the network diagram, everything contained in Tofino CMP is stored in a database on your PC. It's very easy to back this database up, and it's very important to back it up, because if you lose your CMP computer, or if your working database is somehow corrupted, there's no way to get this configuration data back without a backup. We can't help you. It's all encrypted. The keys that are used to communicate with your Tofino appliances are randomly generated. The only way to get those keys is to access them in the CMP database. So how do you create a CMP database backup? There's a command under the Tools menu, Database Admin, Database Backup. This command asks you to specify a file name. It will give you a default that includes the date and time that the backup was created. When you hit the Save button, then a copy of all the various data that makes up your CMP configuration will be created. It will be compressed and it will be saved in one disk file. Here it is right here. It's this file with the TCD file name extension. Back that file up. And if your CMP computer ever crashes, If for any reason you make a mistake and delete something important in your CMP configuration, if for any reason the CMP database is corrupted, you will definitely appreciate the fact that you took a couple of seconds to make this backup, because you can easily restore your entire CMP configuration from that backup file and be up and running in a couple of minutes. Very, very important. I cannot stress that enough. The other issue that I want to mention is that that file should be backed up in a secure manner, because it does have copies of all the authentication keys that are required to control your Tofinos. So you do not want this file getting into the hands of some untrusted party. So make sure it's backed up and backed up securely. Thanks for taking the time to view this video. I certainly hope it was helpful for you to understand how to get the best value from your Tofino system. As always, if you have questions on this material, please contact your local Belden Hirschman resource, and we'd be happy to help you.